Okay, let's unpack this. We have these amazing LLM software engineering agents, right? They can write some seriously complex code, but the second they produce a patch, we hit this massive wall, the verification bottleneck. How do we know if the code is any good? And how do we know quickly?
That verification step is everything. It's critical for supervision when you're training the model, and it's also key for what's called test time scaling, or TTS.
Where you generate a bunch of patches and just try to pick the best one?
Exactly. But the methods we have now force this, well, this terrible trade-off. You
Yeah.
can run full unit tests, which is reliable, but it's insanely costly and slow. The environment setup for each one is just a killer.
And the other side of that coin, the fast, simple checks.
They're fast, yeah, but they're also, unreliable. They don't have the code-based context, so they're basically uninterpretable.
So for our deep dive today, we're going to explore how Scale AI is trying to bridge that gap with something they call Agentic Rubrics.
Promising a solution that's scalable, execution-free, and grounded in the context of the actual code.
Okay, let's get into the mechanics. Phase 1 is rubric generation. How do they build criteria that are actually, specific enough to be useful?
It's all about decomposition and grounding. So agentic rubrics are criteria pulled directly from the repository's context. An expert agent literally goes in and explores the repo. It uses tools to navigate files, inspect things, and then it synthesizes this custom checklist.
Wait, so it's not just reading the problem description, it's using tools to look at dependencies, nearby files, maybe even docs, to build a picture of what a good fix should look like.
Precisely. That agentic context gathering is the secret sauce. It's the expensive part, for sure, but it's what makes the criteria so specific and unambiguous. And once you have that checklist, often a rubrics.yaml file, you move to phase 2. Rubric grading.
And this is the fast part, right? Because it's execution free.
Exactly. An LLM judge takes a candidate patch and just scores it against that checklist. It gives a binary score, a 0 or a 1 for each item. And those items are weighted based on importance. The scoring really focuses on 4 axes: file change, spec alignment, runtime, and integrity.
Integrity. That one sounds important. That's how they catch the agent trying to cheat the system.
It is. It flags things like an agent just weakening a test to make it pass, or deleting a file it shouldn't. It's a critical quality control layer.
But if we're skipping execution, are we just trading one problem for another? How can we be sure an execution-free score actually predicts, real-world success?
The performance data is pretty compelling. On the SWE-Bench Verified benchmark, Agentic Rubrics was the top-performing verifier for patch selection. For one model, the Qwen3 Coder model, it hit a 54.2% resolution rate. That's a full 4 percentage points higher than the next best baseline.
That's a huge lift, and I imagine the value isn't just in the final score, but in the details. It's more than just a simple pass or fail.
That's maybe the most interesting part. The scores correlate really highly with ground truth test correctness and ROC-AUC of 0.886. But they give you this much denser graded signal. They tell you how something failed, not just that it did.
Okay, tell me about the cases where the ground truth test actually passed, but the rubric still gave a low score. What happened there?
Right, so they look into those. And in over half the cases, 54%, the rubric was flagging a high utility issue the tests completely missed.
Like what?
Things like root cause missed, where the agent fixed a symptom but not the real problem, or missing edges where it forgot a key part of the implementation. It means we're not just saving money, we're getting a signal that's arguably better than what traditional unit tests can provide. It understands quality.
And since you're skipping that whole environment setup for every check, the cost savings must be huge.
Oh, they are. For a common metric, best at 16, the average cost for rubrics is about 29 cents. For other agentic methods, it's 51 cents, even 73 cents. So you could run this almost 3 times for the cost of running some competitors twice.
So at the end of the day, this gives us a cheap, scalable, high-quality code review signal. It seems to solve that verification bottleneck that's been holding LLM agents back.
It's a massive step forward. Which brings me to a final provocative thought for you to consider. Right now, this is all about test time scaling, picking the best patch from a batch. But what if you could use this detailed granular signal that catches things like scope creep and missing edges? What if you could use that as a constant reward signal to actually train the next generation of agents?
Yeah.
You'd have to solve for reward hacking, of course, but that's really the next frontier in agent feedback.